My name's Rob. You may remember me from such presentations as Introduction to Command Line Swift, which I gave today, this time last year, from about 8 o'clock. I don't know how that works, thanks to Wednesdays. I'll try not to do a Matt Delves tonight, though, and I won't go for 40 minutes, I promise. One thing I will be touching on tonight is the Swift Package Manager. I'm not going into detail this time, though. If you're interested in Swift Package Manager, check out the presentation from last year on the YouTube channel. Also relevant is the Introduction to Swift on the server that Jet gave April last year. A lot of the concepts are the same, so check that one out too. Before we dive into this, it's useful to put my architect/business hat on just for one slide and say, is this the right tool for the right job? And the answer is definitely no. We're talking about Swift on the back end. There are a lot of more mature implementations of this, like Python and Ruby and other things. But you know what? JavaScript has been encroaching on our space for the last few years. Let's take back a little bit and just do it. I love coding in Swift. This is what we want to do. So the actual presentation of this talk is Swift on AWS Lambda. Is everybody familiar with Amazon Lambda? A few people? I'll give a rough overview first then. So what is actually serverless? It doesn't mean there's no servers, it just means that it's somebody else's problem. Way back in the day when I began coding, you wrote your code, and then you had this entire stack of things that had to be managed. Hopefully, if you're in an organization, you could hire somebody to do all the bits in red for you, but somebody still had to do it. You'd get your server, you'd put it in a data center, or more likely under somebody's desk. You'd have to manage the operating system, install patches, security holes, language runtimes, whatever language you were coding in probably had a runtime, .NET, for example. Then about 20 years or so, along came virtual servers. And they took away a lot of the work involved in managing the hardware mostly. You could now be presented with a virtual machine, or in Amazon speak, an EC2 instance. And all you then had to manage was the operating system and everything above. You didn't have to care about the hardware anymore. And then we containerized, and this is still a very controversial space. Some people love containers, some people hate containers, but the basis of it is that you package your code and any dependencies that it has, and then it can run anywhere that you can run Docker or Kubernetes if that's your flavor of containers. But now with serverless, we can focus. The job is that we hand over our package of code, just your function, just your library of code. You hand it over to a cloud provider, and they take care of running it. They make sure that there's capacity there to run it at whatever scale you like. They provision the hardware, they make patches. The containers that they manage live for seconds, so you never have to worry about security patches, because the next time your code runs, it's in an up-to-date container. So this sounds very user-friendly. You upload your code to a website, and then how do you actually use it? Well, you could run it from the website. There's a test button where you can pass in some input, and it will throw out some output. Or if you're in Amazon land, and for some context, I run the AWS user group here from this spot once a month as well. So this is very focused on AWS. But it's very, very heavily integrated into the AWS ecosystem. So you can sit it behind an API gateway and run Swift code in response to HTTP requests, or Alexa voice commands, or log processing, or event processing, or queue processing, file uploads, almost anything. But the nuts and bolts of what we're trying to do is that Lambda handles the integration with all of those services. They will install and run your code, and all you get given is a JSON payload. And all you have to return is another JSON payload. Everything in between is up to your Swift code. or as we know it in Swift land, it's a function that takes decodable, returns encodable. So to use Lambda, that's more or less what it boils down to. So the reason that I've been wanting to do this talk since the start of the year, and the reason for that is Amazon introduced layers that you could add to your Lambda functions, which is basically just a zip file with some precompiled binaries. But it meant for the first time that you could use custom runtimes. You weren't limited to their predefined list of Python and .NET and Ruby and all of JavaScript, all of those things. About that time, say 10 people on one of the Swift user groups or mailing lists attempted to port Swift to Lambda. Tony Suter is probably one that's got the best implementation, and that's what we'll be talking about tonight. There will be a link. I've actually written just a quick README markdown file that has the summary of tonight's presentation. There will be a link at the end, so you don't need to note anything down. But beware, we're going cross-platform now. So there's no Objective-C here anymore, so there's no Objective-C compatibility you have to worry about. But at the same time, a lot of your favorite data types in Foundation might not be what you expect them to be. The other caveat to this is that Xcode can't build Linux binaries. So to get around that, we need to use Docker. So we're going on to the demo, because it's literally just a intro slides and some demo. Prerequisites, we need to install Docker, and we need to install the Amazon command line tools. The latter is purely so we can manage uploads and stuff without having to use the website. So, let's go. And fingers crossed that this all works for me. Can everybody read that? Is that big enough? Do I need to make the... Are there more old men at the back of the room that need bigger? We'll wait, no problem. So if I did my job correctly, no I did not. Projects, CocoaHeads, cool. You know what I didn't do? Didn't start that. Dun, 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 dun. There we go. Caught up. So Swift Package Manager. We'll just create a basic executable. Again, I go into a lot more detail on this on the talk from last year if you're interested in that. Because we like working with Xcode for some reason, let's create an Xcode project. And then if we open that Xcode project, we get, cool. So it's created the basic template. And my demo for tonight is going to very much rip off Apple's provided demo in the Swift source code Swift website, which is just to return, it's a function that returns a deck of cards basically shuffled. The other thing I didn't start was that. Doing well. No. There we go. So we need to depend on the AWS Lambda Swift library that Tony Suter has put together. And for demo purposes, we need to, I'm just going to import the deck of playing cards example. And then what we do is we let it install as dependencies. Then we regenerate the package. And now if we go to main.swift, it should build. Cool. So, as I mentioned, we need to take two types. One is a request type, which is just something decodable. The other is the return type, which is encodable. I'm just gonna, like, normally you would structure your Swift package with like one file per type and blah, 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 keep it nice and clean. For the sake of a demo, I'm just gonna throw everything in main.swift. Don't do this at home. Nope, wrong paste buffer. Nope, wrong paste buffer. Cool, so we need to import the AWS Lambda Swift library because we're going to use it later. Usual foundation, or not as you know it foundation. Deck of playing card libraries, we define our request incoming decodable type and the outgoing encodable type. So literally our function is going to be, it takes a JSON payload coming in with an optional number of cards and returns those, a string describing those cards in an array. So, build success. So this is our actual function. It's very basic. It just uses the deck of playing cards library, pulls out a deck, shuffles that deck, returns the top, whatever number of cards that you've provided, and then returns that response so that Lambda can encode it and send it off to whoever called it. They do take, there's a couple of models, a couple of different closure signatures that they support here. One is the synchronous returns a result. The other one is it can call a completion handler when you're done. Now this is the magic bit. The runtime type is provided by the AWS Lambda Swift library that Tony Suter wrote. We need to register that Lambda. When you actually go to create the Lambda on the Amazon website, you provide a path to where in that code that you need to execute. So if you wanted to provide a package that had 3 or 4 different functions and 3 or 4 different entry points, we're basically registering an entry point. We're going to call this entry point shuffled, and then it's going to use the closure for that function that we've just defined. So with any luck, we're doing well. Now I mentioned before that we can't build Linux binaries with Xcode. So fortunately, Apple provides official Swift Docker images for Swift 5, so they run on Linux, so you can run it straight away. And for us, that means Makefiles. Makefiles are the unsung hero of classic development. But you provide a list of commands here, and then you can see that we're using Docker to, running Docker, we're going to call it map the current directory into the /source directory on the Docker container, using the Swift Docker image, which is our official 5.0.1 Swift Docker image, and then we'll build. So we can actually see that if I've done this right. So that's going to call into the Docker image. It uses Ubuntu and then the official Swift image. And now you can see that it's actually building it's calling Swift build inside that container. So it has produced Linux binary. So if we try to run that now, Xcode, macOS won't know what to do with it. And the other thing that we've had in that list as well is that in order to send it to Lambda, we just need to zip it up. So the last command there, the package command, just zips up the binary that we build. Cool. Oh yeah, I missed a slide. So now that we have a package, we need to deploy it somewhere. I'm gonna zoom that one. No, not gonna zoom that one. Zoom too much. Okay. So we need to create a function. So this is in the Sydney region for AWS. Create a function. We'll call that function cards, because that's what we're working on. And the important thing is that we select a custom runtime. So you can see the happy children that are actually supported. Unfortunately for us, we're not. We'll go with the default permissions. We don't need to change any of that. Where have I gone too far? So that'll take a few seconds. Cool, that's created our Lambda function. So we now need to go in and set the handler, which is this one here. And so this is the path, the entry path into the binary that you've just built. The binary name is cards, so we call it cards. And then the handler that we set was shuffled. Actually, what I should have done is, yep. And then the other thing we need to do is go into the layers. And so this is all new from November last year. We add in a layer, and we say we want to provide a layer ARN. And here is one that I prepared earlier. So the link to the guide has Swift packages available for every region that you need. Add that in, click save, and that's it. So we have an empty Swift Lambda function ready to go. We just need to upload our code into it. So let's go back to our makefile and add in a deploy command. So the deploy command uses the Lambda CLI client, updates the function code with the name and then the zip file that we create in the package step. Why are my slides out of sync? That's not good. So let's let that rerun. And some build music, I should have thought of that. So that we can't build, with other languages you can just paste your Swift code straight into the website. We can't do that here because they have a 200 meg limit and the Swift compiler is bigger than 200 meg, unfortunately. So that's successful. It's uploaded a new version of the Swift code that we compiled. So now, if we go back over here and we reload this, you should see that our function code is now, so the folder that they can see just has one single cards binary in it, which means we were successful. So to run it, we can go up to the test button here. You need to create some test payloads. So let's, whoops. Oh good, I didn't test this zoomed in. How about now? Nope. There we go, okay. So we can see that we can paste in the example payload that we want to send to the Swift binary. And then if we're lucky, we can hit that test button and it should say test succeeded. Woohoo, demo worked. So that's it. It's literally just taken the input, transformed it, returned the result. It took 301 milliseconds to run. And that's a cold start, so you get billed for 700 minimum, which is about 0.00001 cents that we just got billed for that. If I run it again, there you go, 77 milliseconds. So it's pretty responsive. That's running out of a data center in Sydney. And the main benefit of serverless over the traditional way is that you're not paying for idle CPU time. The exact length that your function runs is exactly what you build, nothing more, nothing less. Well, rounded to the nearest 100 milliseconds. And the final thing is that you can also run that from the command line, which is this one, or any of the other integration methods that were mentioned. So that's it for the demo. There is a couple of caveats. Nope. There's still very much a work in progress. There's basically no error handling with the library that we're using so far. It needs a bit of work. But as I said, it's not ready for production. But the key takeaway is there's no AWS framework for Swift because the one they provide for iOS is written in Objective-C, which has zero chance of working here. So it's unfortunate, but that's the way it is. And that's it. The link at the top has a guide which just summarizes everything that I've just said. I'm happy to take any questions. Jet's got the thing. Yes. Yes, there is.
Someone could probably make that work.
Yes, they could. Thanks for putting your hand up, Oliver.
The shuffle function took two parameters. One was a request that you defined, and another one was a context. Can you show me what the context contains?
Absolutely. So this is all the rest of the information that's passed to your function.
That's set, that's defined as static.
Yep. Yeah, this is very much static. The environment variables you can actually pass in down the bottom here. Down the bottom. So you can pass in any environment variables down here. But otherwise, the key one to know there is the AWS request ID, which is global for every AWS service you touch in case you're doing tracing. More? Yeah?
Did you know if it was possible to get like a framework like Vapor running on serverless?
You probably wouldn't, because that defeats the purpose of having serverless there in the first place. You'd be more likely to stick Vapor in front of Lambda. But more generally, any Swift library you can import to this and run.
So on a scale from showing off on your blog to mission critical deployment for a massive enterprise that's going to sue you out of oblivion, how far along the scale would you use this as a...
Can you put a number on the upper limit for me?
A couple of 100 million.
A couple of 100 million? 5. No, look, in all seriousness, Lambda's in production. It already handles mission-critical workloads. Swift is obviously in production handling mission-critical workloads. The only thing that's still brand new is this layer package, which if the community steps in and actually helps contribute, we can probably get there within 6 to 12 months, unless Apple or AWS does it for us. I'd say the key crossover is after it's been available for 12 months and supported by the community, or either of the two providers provide an official library.
It's kind of continuing from that. Like, do you think there are any features of Swift that would make it worthwhile to use it with serverless? Or alternatively, do you feel like there are other features of other languages that make it more worthwhile to use them rather than Swift?
You can go either way. In the beginning, Lambda was more of a aimed at scripting languages. These days, with the packaging and development tools, you can stick this on the end of a build pipeline very easily. You can then version control your way through it. It's, as far as what Swift brings to the table, it's the same as what Swift brings to the table for iOS over Objective-C. You've got the strongly typed, proper message dispatch, like optionals, things like that. A lot of scripting languages don't have. Like you can't actually run Kotlin on this, for example. You can still run Java, but it's again, it's the same bridge from any of the traditional languages into a modern language and the benefits that you get.
So Rob, one of the things that people complain about with Lambda, because you're getting this thing called start times.
Yep.
We're using Java and .NET and stuff.
Yep. Yes, which we get away with by pre-compiling.
Yeah, so I mean, often you'll find people use Go as
Yep.
in Lambda because it's that liquid file, zero startup time.
Yep.
You see the same advantage with Swift, right?
With this, yes. So cold startup for a Swift instance, Amazon keeps thousands of instances and servers running for Lambda. All it is a managed container. They then deploy your code and all of your layers into that container. So the startup time is literally how fast can it build the container. So it usually keeps all of its assets on S3. How fast can it download your layer from S3? How fast can it download your code from S3 into the container and then spin it up? So Yes. That comes down to if it's precompiled binary or not.
Cool. That's awesome, and also really loud. My question would be just around how usable this is in the near future. It seems to me like the community-driven part, which is the glue, is not huge. Like it's basically going to be something that provides the entry points to the Lambda. So it's
Yep.
it's not a hugely complex thing. So what are the real risks, and why is it only a 5?
I addressed this at the start. It's because it's still brand new. There's no error handling. It's a work in progress. You throw an exception in that code right now, and it's just going to die. Like I said, there's no error handling. You'd want better integrations with the other APIs. So we might provide a decodable input and output, but each of the services that are on this screen has a known and well-documented format. So you want support for those as well.
You say no error handling, but everyone else is using no.
We like strongly typed stuff here. Look, there's nothing stopping you from doing it right now, barring any edge cases that, like the AWS Swift library is open source. Where did I put it? This one. Fully open source, you can go in and fork it, build your own layer and go from there. Like the layers that I've provided links to is literally I've cloned the library, run make deploy. That's about it. But you can dive right into it. So if we have a look. Yeah. Full source code's there. You can dive straight in, have a look at what you're after. Any more questions, guys?
Yeah, so like the serverless framework as it applies to Node.js is kind of agnostic between AWS Lambda, Azure Functions, that thing DigitalOcean provides that I forget the name of. How much do you reckon it would take to get from an AWS-centric Swift Lambda implementation to something closer to like serverless.js where it's kind of platform agnostic with Azure Functions, for instance?
Well, they've taken about 4 years to get to where they are. So if you start tomorrow, maybe 18 months. But the problem with platform agnostic is that as far as I'm aware, other providers don't support custom runtimes at this time.
Any other questions? I have one for you. Is the Apple, the Swift server group, any interested in any of that? Because they have people from Vapor, from Kitura, IBM, and Perfect. Is there anyone that is like within this server group or even at Apple saying, oh yeah, that's something we could be interested in, or is purely community driven so far?
Purely community that I find. Surprisingly, the Venn diagram between AWS entrepreneur and iOS developer is surprisingly small overlap. Possibly I'm the only one in Melbourne that attends both meetups. No, there's actually one other person, so two. Two of us in Melbourne that attend both meetups. I don't know if they have had discussions about this or not. In my searching with Google, I've come across 3 different forum threads, all on the Swift forums, and that's the basis of this. I found that because I was trying to do this myself, but somebody already got there, so yay. Anything else?
No more questions?
Cool. Thanks guys.
Bro.